All right, let's take a look at another example of the use of the chain rule. So here we have considering y is equal to u cubed over u squared plus 1, and u is equal to 3x minus x squared. Determine dy over dx when x is equal to 2. Okay, so recall that, chain rule is utilized when we essentially have composition of functions or a composite function, right? So if we want to basically find the derivative of this function, y is equal to u cubed over u squared plus 1, then the derivative would be the rate of change of y with respect to u, right? If we wanted to find the derivative of this function, u is equal to 3x minus x squared, we would find this derivative as du with respect to dx, right? So chances are if we actually take these two derivatives and we multiply it together and we actually take a look at Leibniz's notation, you can actually notice that you actually get dy over dx, right? So that's the rate of change of y with respect to x. So this is basically a template that we're going to be using. We're going to find each of these derivatives and then we're going to multiply it together. Then we're going to basically substitute x is equal to 2 into the derivative function. So let's first find the derivative of y with respect to u, right? dy over du. And you're going to have to utilize chain rule here. So first I'm going to do is I'm going to do the derivative of the numerator. So you get u cubed times the denominator u squared plus 1 minus the derivative of the denominator, which is d over du, u squared plus 1 times the numerator u cubed. And then this is going to be divided by u squared plus 1 squared. Okay? So when I do the derivative of the numerators, what you're going to see here is you're going to see 3u squared times u squared plus 1 minus 2u times u cubed. Okay, that's just basically the numerator portion. What I want to do here is I'm just going to simplify the numerator before I actually put the denominator down. So I'm just going to expand this guy out. Right, so you get 3u squared times u squared, which is 3u to the power 4, plus 3u squared minus 2u to the power 4, right? So I can combine these two together because these are both like terms, right? So 3u to the power 4 minus 2u to the power 4, you get u to the power 4 plus 3u squared, okay? So basically what your derivative function, I'm just going to write it here, dy with respect to du is basically going to be equal to u to the power 4 plus 3u squared over u squared plus 1 squared. Okay, so that's what your derivative of y with respect to u is. Now if we want to find the derivative of u with respect to x, then what you want to do here is basically you want to do the derivative of this guy, so the derivative of 3x minus x squared with respect to x. And what you're going to see here is you're going to get 3 minus 2x, right? So du over dx is equal to this, right? 3 minus 2x. And then what you want to do here is you want to multiply the two, right? So you have dy over du times du over dx, which is going to give you dy over dx, okay? Now when you do this, what you're going to see here is, let's see what happens here. So what you're going to see here is you're going to get u to the power 4 plus 3u squared over u squared plus 1 squared times 3 minus 2x, right? But we need to also understand that we need to find the derivative where x is equal to 2, okay? So this is a derivative function. All you have to do, and just make your life a lot easier, let's figure out what the value of u is going to be when x is equal to 2. So if x is equal to 2, u is going to be, and you're going to plug it into this equation here, okay? U is equal to 3 times 2 minus 2 squared, which is 6 minus 4, which is basically 2. So u is going to be equal to 2, right? X is also going to be equal to 2. So if I plug this in, you basically get 2 to the power 4 plus 3 times 2 squared over 2 squared plus 1 squared times 3 minus 2 times 2. And that's going to give us 16 plus 12 over 4 plus 1, which is 5 squared, which is 25. And this is times 3 minus, this is 4 basically, right? So 3 minus 4, which is negative 1, right? And this is basically 28 over 25, right? So this is negative 28 over 25. And that's our answer, right? This is basically dy over dx when x is equal to 2. Okay? And that's basically our rate of change, or that's our slope at x is equal to 2.